Introducing to you the OMAKA's assumed factors method of polynomial factorization.
This is Graduating Model Academic Enhancement School GMAT 41. I am Engineer OMAKA, the CEO of GMAT 41. I welcome you gladly to the unveiling of the OMAKA's assumed factors method of factorizing a polynomial and hence obtaining the zeros of the polynomial, that is the root of the polynomial. The OMAKA's assumed factor method is a convenient method and as an alternative to our usual and general trial and error method of solving a problem of this kind. In this method, we are going to see how we can use just few steps to quickly factorize a polynomial. For as long as that polynomial can be factorized completely. In the preview before this video, you may have seen the OMAKA's principles clearly written regarding how to factorize a polynomial and obtain its root using the OMAKA's assumed factor method. Of course, we are going to do that now. Let us see how we explain using this problem the principles you saw in the preview before this video. Now, have this question on the board that says we should factorize completely and obtain the root of the polynomial 2x raised to the power 3 minus 7x squared minus 17x plus 10 equal to 0. Now, how do we handle this problem? The first thing we need to do is to identify the degree of this polynomial and the constant term k. The degree of this polynomial is what? N, and it is 3. Why? The highest power of x here is 3, and that is referred to as the degree of the polynomial. Now we're going to obtain the constant term k, the term that is independent of the variable x. So k here is what? 10. You can see that here. So we're going to get the factors of 10. And let's quickly get factors of 10. Our factors of 10 are 1, 2, 5, and what? 10. 1, 2, 5, and 10 are the factors of 10. Having obtained the factors of 10, what do we do next? We are going to divide the coefficient of x raised to the power n minus 1 by the coefficient of x raised to the power n. What is our x raised to the power n minus 1 here? Remember that n is 3. So if you do 3 minus 1, what will you get? 2. So we are talking about the coefficient of x raised to the power 2, which happens to be what? Minus 7. We are going to divide minus 7 by the coefficient of x raised to the power n, which happens to be what? 2 here, because n is 3. So if you divide this minus 7 divided by 2, we have this. Please, you don't get this in decimal. It's going to be in fraction form like this. Now we will be guided by this minus 7 over 2 to obtain the OMAKA's assumed factor of the constant term. So we write OMAKA's assumed factors of 10. Here, what is it going to be? Remember, you'll be guided by this minus 7 over 2. The fact that this is carrying a divisor of 2 simply means that in selecting the OMAKA's assumed factors, one of them must carry over 2. Now, remember that this is minus 7 over 2. So in picking the OMAKA's assumed factors here, we're going to arrange them in such a way that when you add these factors, you will get minus 7 over 2. So how do we proceed in doing that? Now the OMAKA's assumed factors would be, of course, this is a polynomial of degree 3. So coming to this factor, there must be 3 of the numbers here that will solve this problem for us. And of course, the numbers must multiply to give you 10. Alright? Looking at that clearly, 1, 2, 5 are the numbers that would have to do this for us. 1, 2, and 5. We are now left with which one is going to be plus, which one is going to be minus, which one is going to carry divided by 2, as the case might be. So looking at that, we'll do some tests. We're going to have 1, 2, and 5. Now watch. If I introduce negative sign to this 1 here, and I maintain this as plus, and introduce minus here, you will notice that minus 1 times 2 times minus 5 will give us what? Plus 10. Then we are going to add the factors, remember, to get what? Minus 7 over 2. The number from here that must carry the divided by 2 is either the first factor or the last factor. So we are going to introduce over 2 here and see minus 1 over 2. Add up these and see what you're going to get. If you add up minus 1 over 2 plus 2 plus minus 5, you're going to get minus 7 over 2. Therefore, these becomes the factors that will solve our problem for us. We can now conclude. The polynomial 2x cubed minus 7x squared minus 17x plus 10 is equal to, open bracket, this is minus 1 over 2. So it's now going to be 2x minus 1. Using the denominator to multiply the variable x, then minus 1. Then, going to the second term is going to be x plus 2. There is no denominator there, so it's straightforward, x plus 2. And then the last term is going to be what? X minus 5. These are the factors of this polynomial. Quickly, to obtain the roots or the zeros of the polynomial roots of the polynomial, all you need to do is to equate each of these brackets to 0 and solve for x. And if you do that, 2x minus 1 equal to 0. If you solve for x there, you're going to get that x is equal to what? 1 over 2. Then from the second term, x plus 2 equal to 0. If you solve for x there, you're going to get that x is equal to minus 2. And then lastly, from this, if you equate to 0 and solve for x, you're going to get x to be equal to what? 5. These are the roots of this polynomial, and these are the factors of the polynomial. By factorizing, that explains clearly how the OMAKA as a factor is being used. We're going to solve another problem of degree 4 and see how we quickly get our result. So we have the second question as we run off with the unveiling of the OMAKA's assumed factors method of solving the polynomial problem. In this question number 2, we are asked to determine the solution for the stability of a control system modeled by the function g of x equal to 2x raised to the power 4 minus 3x raised to the power 3 minus 14x raised to the power 2 plus 33x minus 18. Solution. It's important for you to know that a chemical system and even some electrical systems can also be modeled using polynomial equations. Now, how do we apply the OMAKA's assumed factors method to solve this problem? Quickly identify from here that the degree of this polynomial is 4. Therefore, the factors that will solve this problem must be 4 factors. The constant term, which is independent of x, there is what? Minus 18. Now we're going to get the factors of minus 18 quickly. Factors of minus 18 are 1, 2, 3, 6, 9, and 18 itself. But take a look at something here. 6 and 9 as well as 18 are also reducible to the least prime factors 2 and 3. Which therefore means that these 2 and 3 can cover up for 6, 9, and 18. Hence, to get the 4 factors, I'm going to pick out 1, 2, 3 and then repeat 3 again. Why am I repeating 3? Because 9 here has 3 in 2 places. 3 times 3 is going to give us 9. Having said that, remember that you have to multiply these factors so as to get minus 18. Hence, we'll look for sign arrangement here. And what's going to be the sign arrangement? We have minus 1, comma, minus 2. Right, this is positive already. Now, if I make this plus 3, this will still give us positive. If you multiply that, then I will introduce minus 3 to the last term there. Multiply this term, you will get minus 18. The next thing we are going to do is to divide the coefficient of x raised to the power n minus 1 by the coefficient of x raised to the power n, which of course happens to be minus 3 over 2 here. So we're going to write out minus 3 over 2. This will guide us to select our OMAKA's assumed factors. So I'm going to write OMAKA's assumed factors. OMAKA's assumed factors of minus 18 will not be. Remember, this minus 3 has a divisor of over 2, which means that one of these factors must be divided by 2 to obtain our OMAKA's assumed factors. Now, it is either the first or the last term. If you introduce divided by 2 to this minus 1, and add it up to minus 2 plus 3 and minus 3, you're going to get minus 5 over 2. You can work it out yourself. Since that is going to give us minus 5 over 2, it means it can't solve our problem because we are looking for the sum to give us minus 3 over what? 2. Hence, the divisor can't be under this minus 1. Transfer it to minus 3, add up again and see. If we pick minus 1 minus 2 plus 3, then minus 3 divided by 2. Add them up and see. Work it out again with over 2 being under this minus 3. If you add that up, you're going to get minus 3 over 2. And here we go. It means we've gotten our OMAKA's assumed factors, which are going to be minus 1, minus 2, plus 3, and then minus 3 over 2. We are done with our problem. It means that g of x, which is equal to this polynomial 2x raised to the power 4 minus 3x raised to the power 3 minus 14x squared plus 33x minus 18 will be equivalent to, come to this, x minus 1, the next one x minus 2, third one x plus 3, then the last one is over 2, so it's going to be 2x minus 3. And of course, to get the root or the zeros or the solution of this system, we are going to get it to be equate each of this bracket to 0 and solve for x. So the first one is going to be x equal to 1, the second one x equal to 2, the third one x equal to minus 3, the fourth one is going to be x equal to 3 over 2. And that's that. In fact, to obtain the zeros quickly from these, all we need to do is to simply change the signs of what we have here. Okay, that is a fast trick of obtaining the zeros. We have finally come to the conclusion of the unveiling of the OMAKA's assumed factors method of factorizing a polynomial expression and obtaining its zeros subsequently. We encourage you all to work in these and adopt the principle. Solve problems with it. Wherever you have any issue, you can easily contact us. This is our phone number. And of course, you can follow us on our Facebook page at GMATS41 as well as our YouTube channel at GMATS41. Subscribe and follow us up. Remember, most importantly, for the full range of learning, you are free to register with GMATS41, where we make learning fun, easy, homely, targeted, and most especially convenient for you. This is GMATS41. We have magnitude, we have direction, we are vectors. And because Jehovah is our helper, together we can do it.